Hello and welcome. In the last video, we made our back file, was checked to make sure that real-time protection was disabled, and then downloaded a return shell from our box and attempted to do some light obfuscation of the activity. So what we're going to do next is go into Elastic, and let's see what kind of activity that generated from our testing. All right. So if we go into Discover, you can see some logs here from all the activity that just occurred. All right, so what we can do is look into specific data sets. So let's start with something simple. Let's first look at the Zeek HTTP logs, similar to the previous section, okay? All right, so we have our logs here. Let's look at the exact fields that we care about. So let's do get. Let's do the response code. We want the URL path, the extension, and maybe some user agent information. And maybe we want some networking information here. Let's say the destination, okay? So making this a little bit more manageable to read here. So here's a really good view of all the testing that we did in the previous video. So we can see our initial text test files, okay? And then we can see the first couple shell.bats that we sent over the network. And then we can see our more obfuscated attempt where we sent over something called shell.txt, but it's being identified by Zeek as a text file, but then we were saving it as a bat file, okay? So there's a little bit of nuance there. We can see the activities here. Just looking at this data, one possible detection is to alert on suspicious bat files being sent over the network. If you actually looked at something like this in a corporate network, there might be all kinds of bat files getting sent around for different kind of automation used by, let's say, help desk or sysadmins or things of that nature. What you might be able to do is create an alert on bat files and then whitelisting out some of the sources or destinations. Okay, so if you have a singular server that's hosting all those approved files that help desk or sysadmins use, maybe whitelist out those destinations, and that could be a really good potential alert. Okay. You can also have an alert on maybe bat files on abnormal ports. So let's say any bat file getting sent over the network not over port 80. That might be a reason for consideration as well. It really depends on the company you're in and what's considered normal. Okay. So what we're going to do in our next video, based off of this activity, is to create an alert that will trigger on bat files observed on abnormal ports. Okay. The fun caveat with that one is that alert will not trigger in our more obfuscated code. Okay. But once we test the alerts, we can do it one way to make sure it triggers, and then run it the other way to make sure that our obfuscation as an attacker was bypassing the detection we created. Okay. And that's really a key point I'm trying to drive home here is in the cyber defense world, it's a constant battle of cat and mouse on detections that you create, and then attackers find different novel ways to bypass the detections you might have created, and then you'll have to write more detections to alert on those activities and so on and so forth. Okay. And that's what we're trying to emulate here. All right. So that's the Zeek HTTP data set here. Pretty simple. Let's go back to our data and clear this out here. Let's get rid of the selected fields. And let's look at our data set again. All right. So looking at Windows Sysmon operational, this provides a very clear view of what's going on. All right. So what we're going to do is look at some of these. And let's do parent command line, parent name. Okay. And if you notice, a lot of the data here isn't populating. So what we want to do is filter out blank data. So we're narrowing down our view to find what we want. All right. And just doing scroll down here. We can see a lot of Windows activity. And if we keep scrolling, we can start to see some more suspicious activity. Okay. And if you notice, this is actually following exactly the kill chain that we developed. All right. So let's look at the 3 logs here, going from oldest to newest. All right. So we have cmd.exe is executing this testing.bat. And then we have PowerShell that is then getting executed. Okay. So it's an interesting chain of events where we have a bat executing PowerShell. Okay. And if we expand this out, you can see the full text here. So this is the exact script that we wrote, and we can make some detections off of this script. Okay. Okay. So looking at this bottom log line, you can see testing.bat is getting executed by cmd.exe, which is what happened when you double click to run a bat file. Okay. And then what's happening is it's then executing the PowerShell, and going up a tier, we can see PowerShell getting executed. We can see that same command. And then we can see through this command where it's executing that bat file, that bat is getting executed here. Okay. And going up another line, we can see the contents of that shell getting executed right here. So we can see this is that MSF Venom payload that we created. Okay. So what's really fun is you can see the entire chain of events that we worked on in our last video. Okay. So now that we see that we have the visibility, right? We can see the exact chain of events. How do we go about creating detections off of this? There's a lot of different ways that you can go about your detection creation process. You can be very explicit. Okay. So you can say, all right, well, we observed testing.bat in the wild. Let's take these 3 log lines as an example. Let's say these are involved in an active investigation with the response team. This is something we know about and we want to monitor on very specifically. Okay. We can say, okay, we've observed an attacker using testing.bat. Let's make an alert on any hits where testing.bat is executed. Okay. We could go down that route, but it's missing some nuance. All right. If let's say the attacker called the next bat file testing2.bat or example.bat or really anything else beyond testing.bat that would bypass the alert. So ultimately, that's not the best kind of alert you want to make. If you do need to make something like that, you could always have a time to live on it. So let's say you're monitoring for that kind of activity for maybe 30, 60, 90 days, and then you retire the alert and assume the attacker has moved on to greener pastures or different techniques or things of that nature. Okay. But what we can do is be a little bit more abstract in how we're alerting. So instead of being super explicit, we can say something more generic. We can say, let's execute an alert if PowerShell is observed executing from a bat file. Okay. That could be a little bit more indicative of malicious activity. Okay. And it's a little bit more all encompassing. Okay. So if they rename this file, it would still trigger. And that's really what we want to see. Okay. But like I said earlier, there is a balance there. If PowerShell is frequently being used in your environment for IT or sysadmin usage, then that would trigger on those alerts as well. And you'd have to work on some process to tune those out. All right. But for a course, that's definitely not going to be a problem. Okay. So it's going to be alert number 2. We're going to have PowerShell being executed through a bat file, and that will be an alert. All right. And looking at the same log, we could also make an alert for bat files getting downloaded over invoke web requests. Okay. This is going to be a pretty interesting alert because thinking back to our network traffic alert example, if someone is doing this little rename trick here where they're saying shell.txt and they're renaming it to shell.bat, this would bypass that network alert where it's relying on this extension. Okay. But the endpoint alert would still detect it because we can look at shell.bat getting downloaded through an invoke web request. Okay. And that will be alert number 3. And if we go up to our next log here, we can see our MSF Venom payload. There's a lot going on here, right? But what we can do is search for key pieces of this payload and trigger on that activity. So essentially what we're making alert for is default MSF Venom payload generation. Okay. And that would be specific to this PowerShell payload, but it would trigger on that activity. All right. And to do that, we can search on large chunks of text that are contained within this activity. All right. So for example, the only variable piece of information that MSF Venom generated were these variables here. All right. But if you notice, the C variable has nothing to do with the input that we gave MSF Venom. Okay. And if you kind of scroll through and read over it really quick here, you can see that all of this is out of the box what MSF Venom does. So we can alert on a large chunk of this text, and that could be considered a default MSF PowerShell return shell detection. Okay. And that will be alert number 4. We're going to dig into all that more in the next video. Okay. Thanks for sticking with me. I'll see you in the next one.